This is episode 3 of Building a Smart Farm. I'm joined Gabriel Pope. So this is our part 3. We've been tapping away, building up our smart farm. So if we just recap a little bit. In episode 1, we set up a Firebase storage system. So that was where we're going to store our sensor data, and we could manually upload data. And then last week we did integrated Blues wireless sensor data. So using web code, we set up a webhook, which meant data was streamed directly into the Firebase. And this allowed us, so these were the previous charts that used to be done. And this, now it's been running for a week, we can actually see real data coming in. So this is straight out the actual greenhouses. Maybe you can comment on this. What's happened here, Gabriel?
Well, look at that one. That is into the red zone. So the flowers are basically not growing right now, which means if they had planned to harvest one day, they're losing valuable time at the moment.
Yeah.
Everybody has gone, or their product has gone to sleep.
You added this diagram. What's this?
It is. That is the unit, the node that we designed. There's a node card inside, and actually the node card that we have has a sensor that measures temperature, but it's a temperature inside that box. What we have is a cable and a sensor and temperature and humidity sensor at the end of that cord. Why is that important? As plants grow, you need to measure the temperature at different heights. So that's the first thing. So just a sensor that measures temperature and humidity at one height is not relevant for our use case. The second, we need an external antenna. We are in rural areas of Colombia, so we have to have an external antenna to just get the signal from one cell tower, and if that doesn't work, from the next one, and that is Blues provides that capability to just connect to different wireless antennas. And obviously, it has to be completely autonomous. I may have mentioned in a previous episode that we don't get a whole lot of time from our clients, so we have as autonomous as possible. We have that solar panel that basically just keeps that lithium batteries recharged at all times.
Yeah, solar. Yeah, so do you even need to plug it in?
No plug-in. There's a button to turn it on and off, and with very little sunlight, it can work for between 7 and 10 days. So we have plenty of energy. We try to optimize the use of energy for that one.
Oh yeah, that's so cool. So yeah, I mean the big thing about these Blues Note Hub is that it communicates with cellular data. So not only have you powered it with solar, there's no Wi-Fi set up because it's communicating over the mobile phone network. And in this episode, we're gonna send data collected, like dashboards of relevant metrics. We're gonna try and send them over WhatsApp. And why are we using WhatsApp? What's the purpose of that?
Well, WhatsApp has become the universal communication tool. I know that in Colombia, but probably in most of the world.
Yeah, I think everywhere. Yeah, well, it's certainly in Europe, it's extremely popular.
Right. And the thing, as I've also mentioned in the past, is that people that work in the field are more focused on the data around them and in real time, rather than those of us that work in front of computers all day long. In the case of what is meaningful to these people is the current temperature, and that's the greenhouse. As that is actually the sensor installed in that greenhouse that is now warmer than it should be.
Oh wow!
So we have two options. One is to send an alert to WhatsApp, and the other one is for a user inside and at that farm to query the greenhouse via WhatsApp. Just ask the question, hey, sensor in greenhouse 3, and they will get the current temperature and humidity. At that point, what that person has to do is either these greenhouses have curtains, and they also have these industrial size fans. as soon as you get that temperature above that green zone, you really have to open up the curtains and turn on the fans and open up the vents above. And that creates a huge flow of airflow, which really brings the temperature down, but it also dehydrates the plants.
Right.
And it lets the insects in.
Oh no.
So that's that's why it's relevant to be always monitoring for the presence of insects and disease.
Yeah, I mean, this forms like an industrial control process. This is cool. Yeah, so this chart, when we did it last week, it wasn't as fancy as this. So we went back and updated it a little bit to give these color banding and to give it some nice graphics. So this is just using Observable's plot. It's extremely advanced and it's very easy to build things. So what we're doing is just charting this live view data. This green band is the growing zone, as you told us about. Yeah, so we just tidied this up a little bit, but I mean, we had the basics of it working and we've just made it, added in all the dimensions and stuff so it plots nicely. So this data comes from, ultimately from Firebase that we set up in episode 1. This was the other thing I added, was this chooser. So the chooser options are based on the latest cell. If you do Command J, you can jump to the definition. So the latest is we do, again, a query to the current values of the sensors. So doing this query will get us all sensor data, right? Here's our data. This is the Firebase console, the Firebase console.firebase at google.com. So we can look at our real-time database. When we were uploading data, we had the current value, so every time a sensor updates, it just overwrites the current value. So these are the latest values that have been seen in the sensor. But then also, for each sensor, we keep the history, which is prefixed by this timestamp, which is a number. This is a second since 1970. And so that's our main thing. So if we want to know what all the sensors in the field are, we query this current/sensors, which should return these 5. This default sensor name was when we were in episode 1 doing manual uploads, and then these more complex named, these are the ones that are streaming from Blues. Anyway, so if we query the current sensors, take that snapshot, print its result, I think, and then run that, we get an object. That's how we retrieve that data. So now we see all the names of our different sensors, which is useful because now we can populate this chooser. And because we also had those silly ones from last week, from week 1, we just clear them out so we can tidy up the data. This is the beauty of using, actual code to process your data versus like a no-code solution where, you want to do these tidy up operations. Is much easier to do if you can actually program these as data enters and exits the system. So we're looking at this chart. We can select which sensor it does, and then based on what sensor we're currently interested in, so this emits the sensor we're interested in dashboarding, and then based on that we do a query to the history. And then, if we got rid of that, this would query all values in the history, which is going back over a week. We just want to visualize a day. When I was setting this up, we limited it to the last 200 data. Probably what we want to do is, have it in a 24-hour window. So in order to calculate the 24-hour, we can filter when we do a query. So this query is a live query. It will constantly update as new data comes in. It's real time. But what we want is a real-time window of the last 24 hours. So what we could do is, I think it's called start at, I don't want to accidentally query something. So we need to express it in those seconds since 1970. So if I do date.now in JavaScript, this gives us a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 character number. When I look at what we stored in our database, let me just check because I don't want to make a mistake here. Look, the numbers are much shorter. So this is milliseconds. This is in milliseconds, but our data is stored in seconds. So we need to divide that by 1,000. So if we want the last 24 hours, we've got to take the seconds since 1970, and we've got to do this in seconds. So there's 60 seconds in a minute. There's 60 minutes in an hour. There's 24 hours in a day for seconds. That's in seconds, but this date is in milliseconds. So we need to divide that bit by 1,000 to convert it to seconds, and then we need to subtract that. So that number, I would say, is correct, except it's got this annoying decimal point on the end of it. So we can take the floor of that number. Right, so that's seconds since 1970 of yesterday, and this is really what we want to, not that bit. If you find a mistake, it's quite useful with Observer. You can just sort of jump to where the error is. So it was this bit. So we want to start the query at that point, and that should be the last 24 hours. Start at cannot convert undefined to null or object. What does that mean? Right, maybe because this is could be because this is a number. Let's just try changing that to, let's force that to be a string. Does that work? No. Okay, I'm gonna have to look it up. I've deliberately this week not prepared too much, so you're gonna see me struggle a lot more as I have to look things up. So we're working on the real-time database, but I think it's good because then you'll see like how I find documentation and the full process of development, right? So the real-time database, we want to filter data, working with lists of data on the web, Firebase, and we want to filter, was it? Sorting, filtering data, here we are. And what is this for? This is for the database. Start at return items greater or equal to the specified key or value, depending on the order by method chosen. I feel like that is right. Start at. Well, we haven't got much data in the system, so we need to find out where. So I feel like that is correct. And if I execute that, oh, I think it is. Is it executing it? What's this? It's saying there's no data. Ah, I know why it is. Let's try. So, working with lists. Also, maybe it's not clear what we're supposed to be ordering by. So we're ordering by key, and we want to limit order by key and start at that. Ah, yeah, that was it. But yeah, it was confused at what we were starting at because we never imposed an ordering. So we're taking the history, which are indexed by the key. The key, what it means by key is this bit. They're ordered by key, which is a timestamp. So this will be in time order. Do I need that bit? No, I do need that. Yeah. Yeah, so we're ordering by time, and then we're starting at 24 hours ago. So this is exactly now a 24-hour window, it should be. So that's cool. And this is how you query data. This is how you filter data. And this avoids us fetching too much data out of the database. All the load that we'll put on our database, or the amount of data loaded into the notebook, has been limited to that 24-hour window. So whenever you do, Firebase, you have to be conscious that, this data is going to hit your browser session. And if you order too much data and a gig comes in, one, you'll get charged for a gig of bandwidth, which will be a little expensive, but two, you'll just completely slow down that application because you've got way too much data. So it's always important to be, especially when doing historical data, to be conscious of how much data this query is going to consume, and try to always have a limit, really. So that was last week. Is there anything else that we did last week that's exciting, that worth mentioning? Oh, tarot.
Tarot,
Very.
Now, Tom, the tarot is a fun little tool, and I think I have become a little addicted to it now. I think that my my well-being is dictated by the tarot online. But But more than that, I think that the technology behind the tarot is quite interesting. I write something there and it gives me an answer. And I think that this is also applicable to what we're doing. I want to know if, let's say that we have 50% humidity and an average temperature in the greenhouse. What can I expect my population of mites to be, for instance? Maybe you can talk a little bit about both the natural language processing as well as the AI behind it.
Well, the thing about the tarot is, let's do a tarot. I want to do one now. And I'll explain it. Who asked the cards? Last week we asked about how the live stream was going to be. I'm quite confident this live stream is going to be excellent. So what will happen to the price of Bitcoin in the next week? So we can, provide some useful investment advice. No way, it'll be interesting. What will happen? Okay. The Nine of Cups in the past position means that the price of Bitcoin has been stable recently. Stable as in very low. The Queen of Cups in the present position means that the current trend will continue. Okay, so it's going to stay low. Five of Wands in the future positions means that there may be some volatility in the price of Bitcoin in the next week. Well, there you go. You heard it here first. Choppy waters ahead for Bitcoin. So this is tarot. What's cool is, it understands a question in natural language and it responds, it understands the tarot cards and it responds to it. So if you want to find out more for it, there's a link at the bottom here. And this is all just programmed in Observable. So first of all, you'll get like this, the actual application on Observable, and then if you want to like dig deeper, there's like a back end. Oh, just notice they got this rainbow loader now on it. Right, and then here is the gruesome details of how this is actually put together, like individual cards. So when I'm doing like, look. So when I'm doing these animations, I find it very useful to, you don't know exactly what numbers you want to put in to something look the way you want it. What I find easier is to just code 3 parameters and then just adjust them manually until I get the visualizations I want. But anyway, the question was more about like what is happening. We are doing a call to OpenAI, and we simply ask it. So this URL is actually called an OpenAI, and we put in our credentials and whatnot, and we ask it a question, and it eventually responds. But this is a third-party company, OpenAI. They developed this gigantic large language model that is trained on everything on Reddit, loads of Twitter, and it just understands a lot of things. So what I was interested in knowing is whether it understands the cards, because I do tarot card reading for real, and it was interesting to see if OpenAI had actually learnt the tarot, which it appears to, because all its fortunes are consistent with the cards that were revealed. So that's interesting. So so this is just sending it off to an external service that does the actual magic of interpreting the tarot. So that's how it works, and it's all online. If you want to learn how to build like a big application like that, it's all here. So if I get to the guts of it, when we get to how do I actually display it on its own, domain, there's a Firebase backend on this as well. Somewhere, manual deploy. We deploy this index is a Google API website. So this is what it looks like on the cloud account, and then we just slap a vanity domain over that. So, and when I'm actually updating it, so when I push this button, it will actually use my Google credential to update that page, redeploy the app. So this one's deployed via Google Cloud Storage. So in the Observable Notebook, I use it to orchestrate other cloud services, including OpenAI, including Google Cloud. So in order to update the tarot thing, I press this button and it writes into Google Cloud, and now, that reflects in the Tarot Online. So it's pretty simple. But yeah, this is how I like developing, using Observable as a coordinator of cloud resources, which is kind of what we're doing in the IoT, this smart farm service as well. Anyway, so now we know Bitcoin volatility ahead, apparently. So now we're going to do episode 3. That was last week. Cool thing about Observable, we'll just fork this, and now this will be episode 3. We'll come back and tidy this up. This is what we want to send over WhatsApp, right? We want someone to be able to say,
I need to know the current temperature of my greenhouse because I have a crew of people that open and close curtains all day long.
yeah.
Again, it's manufacturing is what it is.
Yeah, it's interesting. These are unstable processes. So if everyone just let go of the steering wheel, everything would be dead, and the cars wouldn't be made, and all the plants would be dead in an instant. It's interesting. So it's just constant adjustment to keep everything running. So we want to send that over WhatsApp because WhatsApp works with cellular data. So let's get to it then. Aims for this week is we want to send dashboards over WhatsApp, respond to inbound requests for data. Yeah, I mean, it would be nice if we did it with an open AI that could actually, do it in natural language. We're not going to be able to do that this week. We'll just do it in we're just going to get the basics working, and that can be expanded in the future. So, but the important thing is we want WhatsApp to be bi-directional. So unlike last week, we had Blue's sensor data was, just coming into us. They were sending it. That was unidirectional data flow from Blue's to us. What's interesting about this integration is we want people to request data and we want to send data. So this is going to be a bi-directional link with WhatsApp. Bi-directional. Integrated with WhatsApp is a little bit complicated. So what we're going to be using is Twilio. Twilio is an external services. Or everything I do in modern software seems to be just, calling someone else's API to make it, to achieve what we want. So Twilio have a nice API. They do lots of things. They can do video messaging, but they also do WhatsApp, which is great. And they are very easy to use. So they have this Twilio programmable messaging API for WhatsApp in a number of different languages, including, now you'd think because Observable was JavaScript, maybe we'd want the Node.js quick start, but when you get into the details of that, basically Twilio has an off-the-shelf library for you to use, and that doesn't work because Node.js makes lots of assumptions that aren't true when programming on the web. So what I tend to go for, and this happens a lot when you're working with Observable, it's a little bit unusual to be doing so much operational work from a browser. So I tend to go for curl, and then because curl I understand what these commands are, and then I just convert them to JavaScript when I need to. So we're just going to go through the quick start then. This WhatsApp quick start will teach you how to do this using the Twilio sandbox for WhatsApp, curl, the Twilio API for WhatsApp, and the web framework of your choice. And we will learn how to send your first WhatsApp message and receive inbound messages. So let's do it. Sign up for Twilio. I think I've already done that. Join your sandbox keyword. WhatsApp sandbox settings. Maybe it's hidden in there. So we've got to somehow join. Here we are. To start your sandbox, send a WhatsApp message to ending in 8886, which is what I've got here. So for 28886, join Spring Read, and then hopefully I'll be in then. Yes. You are all set. The sandbox can now send and receive messages. So, and now we want to send a message. Use curl. Oh, it's telling me to go here. Okay, so first we've got to see if we can send a message. We're not going to do it in curl. We need the Twilio auth token, the Twilio account ID. So let's start pulling these things out. Twilio account ID is not a secret. So that's our account ID. Our Twilio auth token is a secret. So I don't want to expose this on the stream. The way I can do this now, I think there's a, there's a password. So if I type in the password, you can't see it. View of Twilio auth token equals the inputs password. So if I actually print that out, we will see it. So I still have to be a little bit careful. Copy that and put that in here. So now this variable is filled up with my token, but you can't see it. And then what we want to do is post. So now I just convert this to JavaScript. So we want to do a request to a URL. What's the URL? Here. But I want that to be replaced with my Twilio account ID. So we're going to go to the API, that, and then the extra sort of unusual options is it's a post request. So all HTTP requests have verbs to for different purposes, but post is the data-y one. And now, then it gets a little complicated. So then we want the body to be, when you send the post request, it expects it in this kind of format, from equals, but there's an issue where if you're using a weird character, this has to be escaped in a certain way, and that's a little bit complicated to do if you don't know what you're doing, but there's a useful thing called URL search parameters. Is this how we do it? I'm going to search this. Right. How to encode body form data post. Let's just throw some words in it. Can we do it with URL search params? Encoding data for post requests. The body text equals, this is exactly my point. If you encode like this and that text has funny characters, this won't work. So I think there's a really nice way of doing it. New URL search params and then toString. Yeah, this is the pattern we want to do. And I know what he's doing. He wants to do object of entries of, and now we can do it in a nice way. From is WhatsApp. To is WhatsApp ID here, and the body, a bit confusing that it is hello there, and then if we do search params, and then we want to do that dot toString, and we'll see what this comes out as. Right, and now you see the body is from WhatsApp, and it's done. It's replaced that plus. That plus would be a problem. It's replaced it with the encoding. Anyway, that's hard-won knowledge. So this, I would say, is the JavaScript equivalent to this. Let's see what happens. So I'm going to open up the debugger and see what happens when I execute that. We get a 401. So the response, your account SID or auth token was incorrect. Status 401. 401 is denied, and that's because we're missing this bit, which is setting the user. And this is, it's not all that easy to know that when you're doing authentication, you need to send an authentication header. So authorization. So, and this is what they call basic auth. Like basic auth is an actual thing. Basic auth JavaScript script. Basic authentication using JavaScript B2A The user colon password base64 encoded. So we'll steal that code. Look, they've got authorization. Oops. User plus password. And the user is really the account ID. Twilio account ID. And the password is really this token. And then when they do it, you have to also base64 encode it, because that might also contain characters that are unsafe. So the pattern here is that we're constantly doing these encoding things in order to actually send a request. Okay, and what's the header name? Send authorization. I always spell this wrong as well because I've got, oh no, I did spell it right. Oh, I've finally learned how to well, I have to be slightly careful I don't expose my credential here. Let's see. So what happens, so I'll clear the network tab. So when we execute this, hopefully it won't be unauthorized. It is unauthorized. Oh yeah, because I've spelled this wrong. This is headers. Let's try again. 401 again. Ah, yes, there's more to it than just sending the username and the password. You also have to prefix it by basic to say you're doing basic auth. So I've still yet to, so this is really, let's do it this way, basic, and then the credentials go in there. So they're red when they fail. Look, it says the status code 401, so that's what we don't want to happen, is have the status code 401. Fingers crossed. Oh, no, 400. So this is different. Okay, so we passed the authorization check, and this has actually responded with something. So we'll call this the Twilio call. I don't want to dive too much in this tab because I'm accidentally gonna let's call it send message response, and then we can actually look at what the details are. That's the response. We want to see what the payload was. A 2 phone number is required. More info. Status 400. I'm pretty sure we had one. A 2 phone number is required. 2 WhatsApp. What am I doing wrong here? What was the payload I sent? Oh, I definitely sent the right payload. I'll tell you what I'll do. So if I execute this with curl, all I'm going to do is just update that Twilio auth token. So it's always good to debug by just, hopefully that won't print out by. Oh, so that executed. So there's something I'm doing wrong. Maybe it's because I haven't set a content type. This is a HTTP, an annoying detail. I might have just need to put content type. We've got to say what we've encoded it as, maybe. Let's see. Yeah, that was it. Yeah. Okay. What we missed was specifying that our outbound payload was URL form encoded, which, you know, if you understand the internals of curl or inspected it, you would see this header. You know, I normally when I debug these things, I would turn on verbose mode for curl. So I'd put a V here, and then I could see every header sent by the curl command, and I would see that it had. Unfortunately, because we're live streaming this, and I don't want this auth token, I couldn't do the verbose, but that's how I would do it in private. Anyway, so that got sent. I can put any phone number in here, right? Where's my phone? I wonder if I have to whitelist it or something. Oh, do I have to use this user ID? Well, let's try that then. So this is another telephone number, or is that my? That looks like my telephone number. That is my telephone. From the sandbox to this is my personal mobile number. Yeah, hi from observable. So this is cool. So there we go. So that's you know, a little bit of messing around, but we got there in the end. And then what's the next level, what we want to do? So our actual aim, and I'm going to just go to a tutorial here, is to send a dashboard, which is a picture, really. So there's this tutorial how to send a picture on WhatsApp. They're using Node.js. Okay, so we're going to have to figure out how to adapt. Send a picture message with Twilio, and they use a media URL. Actually, does this L work? Let's see if this works. Probably. So if I take that URL, is this a picture that's currently up? Yes. How to draw an owl. Good meme there. Good memeing, Twilio. So let's see if we can just put that over. Well, let's see if that works. So if I send that, ping, I've got a message. Hi from observable, there's no image there. I wonder if it should be capitalized because the other ones were capitalized. Yeah, look at that. So now we can send an image. Right, now we're cooking. And what we want to send is the
current temperature, didn't we? Well,
yeah, I mean, we could send the current temperature. That would be easy. But what would be cooler, we want to send a chart. Sending data viz, I think that's like exciting. Obviously, we can send a number just by manipulating the text. But can we send an image? So what is this? First, let's name it. So we'll call this our dashboard. Like, what is this dashboard when you get into the weeds of what it is? I'm going to delete this. What happens if I just type out what the dashboard is? It's an SVG element. So this is, SVG is HTML. So really, the representation of this image, I think, should be an SVG. And maybe we can just send that. Oh, no, it wants a URL. Oh, that's unfortunate. Yeah, so I can't, so this is image data. What I can't do is pass image data right into that. It needs to be represented as maybe an externally addressable URL. But luckily, this is what like web code's quite good for. If we need endpoints on the internet, we can just create one quickly. So we'll call this the dashboard URL, and async. We'll have an incoming request, a response object, blah, blah, blah. There we are. So this should be live coding. So if I open that, nothing's going to happen because I haven't responded. res.send test. And then if we refresh that, yeah, test is working. So that's live on the internet now. And we want to send, what do we want to send? The image. What will happen if I send that? Let's see what happens. So if I refresh that, oh, look at that. That was easy. Okay, cool. Maybe that'll work. Let's try it. So this is the dashboard URL, and we want to send that as the media. Let's see what happens. So that's executed. Oh, a minute. What did I send? No, that's not. That's the dash point endpoint. Right, that's the full thing. But we want the href is the actual URL. So we want this to be, that's a URL. And it didn't work. Did it give us any clues? This is really JSON. Sending data. This is not updating. So, but if we get rid of this, yeah, I get a message. So it doesn't like this media URL. I think because we've not put enough details in this. So we want to put res.header. This is more content type rubbish. Content type image/svg. I'll show you. So this is a MIME types. Content type, and our image is an SVG. Serve SVG with the correct content type. Add image SVG/XML. Okay, so like this rendered as HTML, we were kind of like maybe fluky that worked. I think this is the correct type. And then what happens when we refresh this? Maybe that worked. Let's just see what happens. So What happens if we send that? No, it fails to send. So we're sending the content type. We can test whether this endpoint works. I know. Let's just check that this is serving an image in the sort of way that HTML should be done. So its source image is, and we can copy that link address. Yeah, this is broken, and there's some extra namespace things you need with SVG. SVG namespace tags or something. I don't know. Blah blah blah. Yeah, you need this on there, which I know Observable doesn't do because it doesn't need to. This is more technical rubbish. So the SVG is missing. I don't think that's the issue, but it might be the issue. Let's try it anyway. Let's go dashboard dot XMLNS equals that, and then send it. And then what happens when we refresh that? Does that work? Does it give us any clues why it doesn't work? Let's ask the system. Let's get a clean reading. So this, it has no data. Response headers, content type SVG, get preview, and then it's not been encoded properly or something.
Can you save it from SVG to PNG in Observable?
I tell you, like serving, you are right that serving PNGs is maybe. I've got an example of serving a PNG, so let's see if that helps us. Serverless cell tests. I've got these tests that I run whenever I deploy a new version. I run all these automated tests which help diagnose things, but one of them is an image. This is how I serve. This is how you serve a PNG properly. Would be endpoint. Okay. So if I click this one, what happens to that one? Yeah. There's what's in that? Nothing. File attachment logo.blob. Oh, actually, we've got an image here. Let's copy that one then. File attachment image.png. Let's see if this works. Ah, cool. Yeah. So that image. Yeah. Okay. So that's working. And the way we did it was we got it as a blob. What is a blob? This is all a bit blob. This has its own type, I bet. Dot type image dash PNG. Yeah. So the content type is image slash PNG. What did we go in? Image slash SVG. So we were right on the header bit, and then I think it wants to do it as binary data. So let's try that and see. Whenever you're confused on what to do, it's always worth looking if anyone else has done it. So it's called this XMLMNS saving SVG. Oh look, Mike Bostock, the founder of Observable, has an opinion on this, so his opinions are usually correct. So how does he actually set it? Look, SVG set attribute, serializer, serialize the string, return a new blob. Oh, look at that. That is beautiful. This is exactly what we want. That looks like perfect. This is kind of what I was messing about trying to do here, but this looks like the proper way. So I am going to copy all that then. So it was called, the dashboard was the SVG. What else did it? Actually, it's just got a whole thing. Let's just copy it. Oh look, and here's how you convert an SVG to generate a PNG as well, rasterize. So we could do it that way as well. Let's keep it. The nice thing about SVG is it doesn't lose resolution. So serialize, yeah, that's great. That's just one block of code. And I think then, and this is a function of an SVG, so we want to serialize our dashboard. Let's see if this works. And now, fingers crossed, come on. We can view the page source. Yes, it is empty. You are correct. So this serialize was returning a blob. We've just skipped a couple of steps there. Then we have to, so this would be, this returns a blob, then we turn it to an array buffer, then we send that. Is that right? Come on, last hope. Yes! Oh my word! Woo! There we go. So, yeah, so this is nice. So we've used web code to create an endpoint, and through manipulation of the right HTML content type and some severe pain in trying to figure out how to serialize an SVG properly. So these plot diagrams that are, this is a pattern I think many people will want to do, right? Because this plot tool is just phenomenal, and it generally outputs SVG. And now we can connect. So this dashboard is live, right? Every time, obviously, there's no new data, but this is live data. This dashboard's connected to live data. And so now we can serve it as a, I'm going to kill that one. We'll get rid of the PNG. We can do PNG. So yeah, so now we've created an endpoint. We don't need this one. So this endpoint now serves an SVG in the proper way that you should do it. So fingers crossed, this is your HTML should be able to just refer to that as any other image. Yeah. So this is working. This is actually coming through web code. So that's now a bona fide working URL for for a URL. So this should now work. Yeah, I could hard code it, or we can just dynamically whatever that is. I bet it doesn't work. Let's hard code it actually for now. No, let's not hard code it. No, this should work. Let's see what happens. No. So it still failed. Right. I have a suspicion. I wonder if it just doesn't like SVG data. Do you wonder? Yeah, probably that's true actually. Should we look at that? Twilio SVG send messages WhatsApp. It might just be a limitation. Send an SVG. Oh. Yeah, okay. So you have to convert. Well, certainly this tutorial. Oh, and it's on Twilio. Sending SVG images, but a notable omission in the list of supported formats is SVG. Damn it! So that was a waste of time. But we're on the right path, so we can also do it. I wish I hadn't deleted all those things. We can use another feature now, because I deleted some cells that I now regret. So we can look at our history. I removed rasterizer then, so we can scroll back a bit. And where was that endpoint that was working? That was removed. Go down to here. This was the PNG endpoint. This was working, so I won't revert it. If we revert, it will delete our later changes that were working as well. So this is our SVG endpoint. I'll keep that going because that's quite cool that works. Does this stop working? No, that is working. And now we'll do our PNG one. So our PNG link is that this we're expecting to work, yes, but it's not our dashboard. We need to rasterize it, and this rasterize ends up returning a image. Oh, all it does is just okay, let's see what this actually does. It seems to build a canvas, writes in the SVG, and then returns a promise which resolves to Y. What the hell is Y? I can't follow that. I'm not going to try. So we want to rasterize our dashboard. Oh, have I not import? I haven't got it. I should probably just import it. And then it's linked. Now it's linked. I love this with observable. You can just follow the dependencies. Now we know where we are. So this returns a blob. Okay, so rasterize returns a blob. We know how to deal with blobs. We wanted a blob there, so this is the new version. Oh, why is it so small? Let's try again. Oh yeah, there we are. Oh, I don't know what was wrong then. Maybe I needed to await it. Anyway, Oh yeah, we do need to await because it was doing all that image loading. Yeah, so that was an IO. Yeah, it was missing. Yeah, we needed that await because this rasterizes an async process. Anyway, so look, this is now a PNG, not an SVG. So fingers crossed. Fingers crossed we can send that as the media URL. Didn't do it yet. Let me just check this is all working again. Send it with nothing. Oh, what? Maybe, oh. New image. Oh, your account SID or auth token was incorrect. Ah, I've managed to somehow lose my auth token. Oh my god. Does that mean that was the issue all along? Let's see. Yeah, because I refreshed. Yeah, when I refreshed it, I lost my token from there. Okay. My auth token. I need that in there. Yeah, so this said it wasn't right. Oh, here we go. New image. Execute it again. Oh, look at that. Oh, that was, we had to fight for that one, but there it is. Dashboard over WhatsApp. Yeah. There we go. Oops. Cool. Ping. Yeah, we sent it again. Okay, so that's cool. So that's one direction of data flow. How are we doing for time? We're kind of over time. How are you doing for time?
I'm
Okay,
fine.
I'll have a quick look at. Okay, I'll just look at some of the chat messages. What makes you choose the Firebase real-time database versus Firebase data store? I think it means Firestore. Why are we using the real-time database over Firestore? Good question. Yeah, so Firebase has two databases. I was an early employee of Firebase. I originally worked on the real-time database. So for one thing, I'm more familiar with that. But I did help work on the Firestore database as well. Firestore is like the Google version, which has many improvements about querying and such like. But Firestore has quite significantly bumped up the price for the writes. So for IoT workloads, which tend to be very write heavy, Firestore can get pretty pricey, and I think the real-time database is better. The other reason why I like the real-time database is it's WebSocket transport based, and it achieves lower latency. So like Google used all its incredible database technology to build Firestore, where if you do a write to Firestore and it accepts it, there's no way it can ever go missing. Each write as a Paxos group is written into 5 different regions. That data is safe. There's no data loss risk. Whereas the real-time database, this was developed by a startup, a bit scrappier. Ultimately, the back end, there's only one. There is data duplication, but it's not cross-regional. So you would say there is a slightly higher risk of data loss with the real-time database. Now, for an IoT workload where every sensor is basically printing out pretty much the same value as it did 5 minutes ago, data loss is not something to be that scared of if it's a rare occurrence. And what you want is your dashboards to be as fast as possible. You want to optimize speed over durability, which is exactly the trade-offs that the real-time database makes. It's the faster database, worse durability guarantees, and cheaper as a result. So when you think about time series of sensor data, that matches pretty well. So that's why I think it's the right choice for this particular application. Yeah. So that's one of our goals were send dashboards over WhatsApp, yes, and then respond to inbound requests for data. So now we go back to our tutorial. So how far did we get? Send a message with WhatsApp, receive and reply to messages from WhatsApp. So this is to get the full bi-directional. So we want workers in the field to say, parachute me in some data, we can send the data, we know how to do that, but we don't know how to actually receive the data. This will be kind of similar to the situation last week when Blues Wireless was sending us sensor data. So the direction of data flow is coming from the third party into our system. So someone's going to say, hey, send me some data. It's going to be initiated by an external party, and we're going to have to react to it. So we have to make our system responsive to external events. So this says we need a webhook. We used a webhook for Blues Wireless. We're going to use a webhook from WhatsApp. So when someone replies to one of your messages, you will receive a webhook request from Twilio. You can configure webhooks by connecting your sandbox to an app you've already built for handling incoming messages. Blah, 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 blah. So where do I actually configure that? That was it. That was the quick start. That was very brief. Okay, so we need to configure this webhook. Right? Presumably, what is a webhook? Where do I configure this? I guess it must be in these settings. WhatsApp sandbox settings. Is it sandbox settings or general? When a message comes in, do a post to some random place. Like, it hasn't given me much information on how to authenticate this, so we'll just do our best. So webhook. So now we need another. This will be for what's unusually send OK. That was exactly the case when we did Blues last week. So this is the WhatsApp web. Unterminated string constant. Yeah, sure. Okay. So now we have a webhook, and I put a debugging statement on it so we can see when it gets called. So if I manually call it, I should expect that to pause, and this has got caught in the debugger. This is held up. When I press play, this resolves and says OK. So we're able to live intercept this based on this URL. So instead of me triggering it, we want Twilio to do it. When a message comes in, call that. Now this is good because the documentation is not being very good at explaining what's going to happen, but I don't need to know that because we're just we'll figure it out from data as it actually happens. So I think that's all we need to do. There's no save button or anything. We just, oh yeah, there is a, okay, save. So we're expecting this thing, so hello, and will this pause? Yeah, this is paused now, and now we can inspect what's actually come in. We've got, you have to stare a little bit. In the request has a body, SMS message ID, blah 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 blah. Oh, it's kind of complicated. Yeah, so what I'll do the same as we did with Blues Wireless. This is too complicated to follow in the debugger. Did this okay, I had a message come in. This is too complicated for the debugger, so let's unroll. Instead of trying to do everything in this one cell, which is going to get crowded, we're going to create a view of WhatsApp event, and we're going to use the flow queue construction to convert this callback based API into a number of cells. So we want to see what comes in, and then when we've eventually processed it, we want to resolve it. We'll resolve it to OK. Nothing's executing it yet. To use a flow queue, we send it data. We're just going to package everything up. Request, response. Sometimes you want context. So this is going to resolve to something. So we await on that. And then instead of hard coding it, we'll respond to whatever was resolved here. This is the happy path. This is if everything pans out as we hoped. Whenever you await, you should really catch, just in case there was an error. So if there is an error, we usually want to put a status code to say something went wrong. Status 500 means server error, and send. And to get help on what the error was, we'll just print out the message. So this is like my standard. If I'm doing a complex server, I'll always just put it out over the flow queue, because this will give us visibility without us having to use the debugger. So it's not very interesting yet. No data has gone into this flow queue yet. We're waiting on a endpoint, a message to be sent. Hello? And now I hope, yes. So this, while we were over there, look, it's so fast. That was incredible. Instantly, this resolved, and now we can look at our own leisure. Now we can work on the implementation, right, without having to keep resending data to figure out whether it's working or not. This is the power of live coding with web code. And I don't think we actually resolve. Yeah, we'll get to that. We'll get to how we handle it. So we've got this event. It's got a request. It's got a body. This body, now it's this weird format of equals and ands. It's our old friend, the URL search params. Wait a minute. Where did we last use it? We used it right at the beginning. This was to encode it, but we want to decode it. I think we just do it something like this. New. So I've got these set parameters. Oh, and I think they have a method called entries, which is an iterator, and then I can go object from entries to decode that. Okay, so now this is the WhatsApp incoming. So it tells us who sent us a message, and I don't want to get too worried about hopefully you can understand. Look, we can see what was said was hello in the body. So the message was that incoming WhatsApp /body was hello. And now, what do we want to do in response to that? We want to, when a message comes in, we might want to conditionally consider what we're doing. So if the message equals, what should we call? We'll say chart, else. So if the incoming message is chart, then we want to send a chart, right? So we know how to do that, but we did it somewhere else. We could now send a message in response. Now I would probably structure this a little bit nicer. From WhatsApp, we want to send it to the person who sent it. The incoming message had to, and it came from. We want to send it to the person that sent us the message, right? From, right. So we want to respond to the person that the message came in on, the incoming message, and we want to say your chart, and we'll send them the latest data, which is from that PNG. Otherwise, we still want to send data, but this time we don't want to send a chart, and we say I don't understand.
Can you quickly get the current data from the sensor?
That is the current data from the sensor. I mean, it's the graph of it.
Oh,
you want here. Here you want. Okay.
Yeah.
I don't understand. We'll say we don't understand your message. I don't understand the message, but the temperature is. And now we need the current data. Do we have the current data? Yes, we did have it. Latest has it. We'll just send all the latest, shall we?
Mm-hmm.
Okay, so this is not compiling. So the latest is all the sensors. Yeah, we've not. Well, that's too much data. Let's
Latest body temperature.
we'll just send dot body. Oh yeah, that looks a nice amount of data. That's in an object, so we need to turn it into a string, and we'll send them that in response. Okay. I don't understand hello, but the temperature is, so I want a chart please. Fingers crossed. And it hasn't worked, and I know why this, I bet it will work now. Your chart, and if I send nothing, right, this is like one of the annoying things about the way Observable is structured is the JavaScript does not run if it's not the current tab. So it's paused and then it will work. As soon as I switch tabs, you see it work then? So in order to keep that running, we have to put it like this. And now this should work a lot quicker now. So if I type gibberish, yeah, you saw that update? Yeah, this is cool. Look, you see the message, hi come in, and it responds. And I want the data is a bit slower because it has umpteen requests to do. Yeah, and there we go. And it responds with the chat. That's it.
Beautiful.
On-demand responses. So I should put you a few little warning bits here because this whole WhatsApp integration relies on this API key that I plugged in somewhere. Yeah, this Twilio token. So I'm live coding, so all this stuff has been executed in my current browser session, which is aware of the auth token. But if I close this and let the server handle it, it won't work. It won't work because this is unknown. So the way you would need the bit that's actually doing the conversation. This would need to be passed in, and this is what secrets are for. So we would need to add a new secret. This would be the Twilio secret, and we would have to take it out. That context payload would include the secret inside here. So if we look at our context payload, at the moment we're not passing in any secrets, but in order to get this to work reliably, even when I wasn't currently sat at my desk, we need to move the Twilio secret into a proper secret payload there. We kind of did it, the one we did last week with Blues Wireless, we did more expansion on the secret stuff. So if you need to see how that works, I would say go back to next week. It's not really worth us going over that ground again now, but just FYI, this won't work as soon as I close because it won't have the ability to post back to the Twilio API. Any other questions? Anything else we need to cover?
I think it's taking us a little. It's taking you a little more than we had originally planned, but you did everything. You did both.
You cut out then. We did both. Uh-oh. Hello, are you back? Well, I will call that a day anyway because we seem to have lost Gabriel. I hope that was interesting for you. So our smart farm, we can now collect data, store data, draw dashboards, and send that dashboard information over WhatsApp, all over cellular networking technologies, which I'm quite excited about because this means we can deploy this kind of technology, in many parts of the world. The plan for next week is, at the moment, Firebase is very limited in its query expressivity. We want to have a go on these new observable SQL cells and do roll-ups, aggregations, the kind of data processing that you would like to do on this data. So ultimately, it's about the point of having data coming in. There's no point in having data if you're not going to act upon that data. And this is important for closing this control loop. So if the temperature's too high, we need to alert people. And in order to know if the temperature's too high, or maybe our plants are growing too fast and Valentine's Day is miles away, so we need to actually deliberately slow down the data or something. This all revolves around quantitative analysis of the data that we're collecting. Now, to do good quantitative data analysis, Firebase databases are not the right choice. You want a SQL database thing. So next week we're going to explore getting our data into SQL so that we can perform high quality data analytics on it, and this will be driving our actions ultimately. So I hope you join us next week.